Hello everyone, welcome to Standard 6 Physics class. In today's video lecture, we discuss about chapter 6 which deals with magnetism. In this chapter, we will discuss about magnet, properties of magnet and its type, magnetic and non-magnetic materials, Earth's magnetism, making of magnets, electromagnets, handling of magnets. So let us first discuss the magnetic different properties of magnets and the various types of magnets. Magnet is a rock or a metallic object that can attract certain type of metals such as iron, nickel and cobalt towards it. The property of magnet by virtue of which they are able to attract these materials is called magnetism. The property of magnet by virtue of which it attracts the materials like iron, nickel and cobalt towards it. This property of magnet is called magnetism. The force by virtue of which magnet attracts the magnetic objects, magnetic materials towards it is called magnetic force. The property by virtue of which the magnet attracts the magnetic material towards it is called magnetism, and the force by virtue of which magnet attract magnetic materials towards it is called magnetic force. Clear? Now, different types of magnet. Now we'll discuss about the poles of magnet. A magnet has two poles. One is the north pole and other is the south pole. You see, this is the north pole of a magnet and this is the south pole of the magnet. The end of the magnet that points towards the geographical north pole, geographic north is called the north pole of magnet, and the end of the magnet that points towards the geographic south pole is called the south pole. Geographic south is called the south pole of the magnet. The two poles of a magnet cannot exist separately, so they all exist in pair. It means that magnetic poles always exist in pair. South pole cannot exist without the existence of north pole, and similarly, north pole also cannot exist without the existence of south pole. So these two poles, if south pole exists, then definitely north pole will exist. If north pole exists, then definitely south pole will exist. It means that these two poles always exist in pair. North and south pole of the magnet always exist in pairs. The space around a magnet where its influence can be felt is called the magnetic field. Each magnet generates its own magnetic field. Any magnetic object within a magnetic field gets attracted towards the magnet. If a magnetic substance is placed within the magnetic field of a magnet, then the magnetic substance gets attracted towards the magnet. Another magnet within, however, if another magnet is placed within this magnetic field, it will either be attracted or repel depending upon the orientation of the two magnets. Now, types of magnet. Magnets are categorized on the basis of their origin and the time for which they are retain their magnetism. On the basis of this, magnets are classified as natural and artificial magnet. So first of all, we discuss about natural magnets. The magnetic materials that are found in nature are called natural magnet. The magnetic materials that are found in the magnet are called natural magnet. Magnetite is an example of natural magnet. Now DPSL magnet, the magnets that are made by humans are called artificial magnets. They are made from pieces of iron in different shapes such as U-shaped, bar magnet, ring magnet, and horseshoe magnet. These are the different types of or different forms of artificial magnet. Now we discuss about permanent and temporary magnet. Based on the time for which magnet retain their magnetism means the time for which a magnet retain their magnetic property. Magnets are classified into two categories. One is temporary magnet and another one is permanent magnet. So what is temporary magnet? Some magnet lose their magnetic property as soon as you remove the magnetizing forces such as electricity in case of electromagnets. Such magnets are called temporary magnets. It means that if there are certain magnets which retain their which retain their magnetic properties for certain time only, as long as the magnetizing force act on them. Such type of magnets are called temporary magnets. Permanent magnets, magnets which retain their magnetic property for a long time are called permanent magnet. The magnets made from neodymium are one of the strongest permanent magnet. This is the example of permanent magnet. Properties of a magnet. First property, poles of a magnet always exist in pair. You see, north and south pole of a magnet cannot exist in isolation. It means that north and south pole of a magnet always exist in pair. These two always exist as pair. If you got a bar magnet, this is a bar magnet. This is the north pole and this is the south pole. Now, cut the bar magnet into two halves. Each half becomes a complete magnet, having both north and south pole. This is one half, it also contains north pole and south pole. This is the another half, this also contains north and south pole. Now these two halves becomes a complete magnet. Now if we continue to cut these pieces into two, each piece becomes a complete magnet by containing both north and south pole. North and south pole. So poles of magnet always exist in pair. The second property is attractive property. A magnet attracts magnetic substances such as iron, nickel and cobalt towards itself. This property is called the attractive property of magnet. The iron nails are getting attracted towards the magnet. This property of magnet is called attractive property of magnet. Third one is the directive property. A freely suspended magnet always comes to rest or aligns itself in the north and south direction. This is called directive property of magnet. The end of the magnet that points towards the geographic north is called north-seeking end or north pole of the magnet, and the pole of the magnet or the point of the magnet which points towards the geographic south is called south-seeking end or south pole of the magnet. Now the fourth property is like poles of a magnet attract each other, whereas unlike poles of a magnet repel each other. Like pole means north pole of one magnet and north pole of another magnet. South pole of one magnet or south pole of another magnet. These are called like poles. Unlike pole means no, south pole of one magnet and north pole of another magnet. So when the unlike pole means south pole of one magnet and north pole of another magnet are brought close to each other at that time, these two poles of the magnet gets attracted. While the like poles, but in case of like poles, when the south pole of one magnet and south pole of another magnets are brought close to each other, they move apart from each other. This is called the like poles repel each other. These are the four properties of the magnets. Now we discuss about magnetic and non-magnetic substances. Magnet attracts certain substances towards it. Some materials do not get attracted by the magnets. So on the basis of their tendency to be attracted towards magnet, we can classify the material as their magnetic or non-magnetic material. Materials that are attracted towards a magnet are known as magnetic material. All the objects made up of iron, nickel, cobalt are magnetic materials. Materials that do not get attracted towards a magnet are called non-magnetic materials. For example, wood, plastic, aluminum, copper, cloth, etc. These are the examples of non-magnetic material: wooden ruler, matchstick, plastic spoon, glass seat, gold ring, and rubber band. These are the examples of magnetic material: iron nail, steel spoon, steel ruler, iron needle, iron key, pin, iron. This pin is made up of iron, safety pin, etc. Now we are going to discuss about Earth's magnetism. Whenever a magnet is suspended freely, it always aligns itself in the north-south direction. The south pole of the magnet aligns near the geographic north pole. This is, you see, this is the magnet. This is the south seeking pole and this is the north seeking pole. The south pole of the magnet aligns near the geographic north pole. This is the geographic north pole and this is magnetic south pole. And this north pole of the magnet align itself near the geographic south pole. This is the geographic south pole and this is magnetic north pole. This is because the earth itself behaves as a huge bar magnet. Magnetic poles of the earth correspond with the geographic north and south pole of the earth. The earth's magnetic north pole is present towards the geographic south pole and the earth's magnetic south pole is present towards the geographic north pole. Thus in a freely suspended magnet, the north pole of a magnet points towards the geographic north pole since it is attracted by the earth's magnetic south pole. In the same way, the south pole of a magnet points towards the geographic south pole since it is attracted by the earth's magnetic pole, earth's magnetic north pole. Clear? Now making a magnet. How to make a magnet? Magnets can be made from magnetic materials such as iron, steel with the help of other magnet. The magnet thus obtained are temporary or artificial magnet. So magnets can be made using various methods. Some of them are discussed. First one is the single touch method. In this method, a magnetic material such as iron rod is placed on a flat surface and struck along its length with a bar magnet in the same direction. When the magnet reaches the other end, it is lifted and brought back to the previous end. This process continues and is repeated for 20 to 35 times. So the iron fillings or the other magnetic substances is brought near the iron rod. The iron rod becomes capable of attracting iron fillings, which indicate that iron rod become a magnet or gets magnetized by this process. Another one is a double touch method. In this method, the double touch method, place a iron bar on a wooden table. Mark its one end as north and other as south. Place the north pole of one magnet and the south pole of this is the north pole of one magnet and south pole of another magnet at the center of the iron bar. Now slide two bar magnet outwards towards the end of the bar magnet. Lift the magnet. In the third step, the magnet bar were lifted and bring them back to the center of the iron bar. Repeat this process 20 to 30 times. After doing this process, the iron bar will be able to attract paper clips. So, after repeating the process of double touch method for a while, iron bar returns but turns into magnet or gets magnetized. This is the process of double touch method. And the third one is the magnetic induction, a phenomena where a magnetic material temporarily acquires magnetic properties when a magnet is brought near it is called magnetic induction. This method is generally used to make temporary magnets. The magnetic properties of the substance disappears the moment the influence of the magnetizing substance is removed. This is the perform this activity to know to make a magnetic induction. Hang the bar magnet. This is a bar magnet. Hang the bar magnet on a wooden stand. Bring one clip near the magnet. One clip is brought near the magnet. Now bring another clip. Repeat the above step for a few times. Dissociate the very first clip from the magnet and observe how this affects the rest of the clip. Now you observe that the bar magnet attracts the first paper clip. This clip then attracts the second clip and so on. But as soon as the first clip is removed from the magnet, the rest of the clips also pull down. If this clip gets removed from the bar magnet, other clips also pull down. This is the method of magnetic induction. Now we discuss about electric current method. In this method, magnetization of soft iron bar or a nail is magnetized using electric current. So we need a iron rod. This is the iron rod, a dry cell, a key. This is the copper wire. Wound the insulated copper wire. This is the copper wire. Wound the insulated copper wire around the iron rod. This is the iron rod. The iron rod is wounded by insulated copper wire and connect the two ends of the battery with the insulated copper wire. Now allow the electric current to pass through the wire. Bring the paper clips near the ends of the iron rod. After a while, remove the cell and again bring the paper clips near it. As soon as the current passes through the copper wire, the iron rod attracts the paper clips which are brought near to it. When the current is turned off means when you stop the current flowing through the copper wire, the iron rod does not attract the paper clips. So as soon as the current passes through the copper wire around the iron rod turns into a magnet. This magnetic property of iron rod is lost as soon as the current is turned off. That is called electromagnet. The magnet formed in this process is called electromagnet. Electromagnets are made by passing electric current through a long wire wound around a soft piece of iron bar. And electromagnets are used in doorbells, electric motors, etc. Electromagnets behave as a magnet as long as the electric current flows through the wire. They lose their magnetism once the current is switched off. Strength of the magnetic electromagnets. Strength of electromagnet depends upon the amount of electric current flowing through the conductor. And the number of turns in the coil. This is the number of turns. The strength of an electromagnet can be increased or decreased by increasing the strength of an electromagnet can be increased by increasing the number of turns in the coil. The strength of an electromagnet can be decreased by decreasing the number of turns in the coil respectively. Third point is the material of the core of the electromagnet. A bar made of soft iron is the best choice for magnets. Steel or cobalt may also be used as the material for core of electromagnet, but generally soft iron is used as the core of the bar magnet. Now, handling of a magnet. Magnets should be handled and stored carefully so as to prevent loss of magnetism. Bar magnets should be stored in a magnetic keeper. This is the magnetic keeper with their unlike poles on the same side are separated by a piece of wood. Magnets should not be heated, hammered, or allowed to fall on a hard surface. This makes the magnet lose its magnetism. This phenomenon is referred to as demagnetization. Magnets should be kept away from computer, television set, and all electronic items, as these can demagnetize a magnet. So this is all about this chapter magnet, and with this your chapter is completed, and this is the last chapter for the annual examination. I will give you the syllabus of physics for annual examination, and you prepare well for your examination. So thank you very much for watching this video.